myself Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study some of the steering gear mechanisms and their problems. One of the steering gear mechanism here it is the Ackerman steering gear mechanism. So in this Ackerman steering gear mechanism, it is a simpler mechanism in comparison to Davis steering gear mechanisms. In the last class we have studied the fundamental, what is the condition for correct steering or equation of the exact steering gear, that is cot phi minus cot theta equal to W by L. And one more, there are two types of steering gear mechanisms are there. One is Davis steering gear mechanism, another one is Ackerman steering gear mechanism. Okay, this is in the Davis steering gear mechanism. We understood that the condition here it is came into the picture that tan alpha equal to C by 2B. This is the equation obtained after satisfying the condition for correct steering. The condition for correct steering that equal to, that is cot phi minus cot theta, that equal to C by B or W by L. In some of the books they followed that it is W and it is L, or it is C by B. So 1 by tan phi minus 1 by tan theta equal to C by B. After substitution of what is tan phi and what is tan theta, the equation obtained is tan alpha equal to C by 2B, where C is the distance between the two pivot points and B is the wheel base, where B is the wheel base. Okay, now this Ackerman steering gear mechanism is a simple mechanism in comparison to Davis steering gear mechanism. The difference between the Ackerman and steering gears are whereas in Davis steering gear mechanism there is a slider, but the whole mechanism of the Ackerman steering gear is on back of the front wheels, whereas Davis steering gear is in front of the front wheels. In front of the front wheels means there the front wheels are there. This is controlled by, this is the Davis steering gear, whereas the Ackerman steering gear it is in front of the, just on back of the front wheels. It is in the back. It is not in the front wheels. It is in the back of the wheels. So next point, number 2 point, the second difference is that Ackerman steering gear consists of turning pairs, whereas the Davis steering gear consists of a sliding members, consists of a turning pairs. Ackerman steering gear consists of turning pairs and Davis steering gear consists of sliding members. So main thing is that here the coefficient of friction, one more important difference is that the coefficient of friction is high in the case of Davis steering gear mechanism in comparison to Ackerman steering gear mechanism. Okay, so that is one of the third point is that coefficient of friction. The coefficient of friction is high in comparison to the case of Davis steering gear mechanism, in comparison to is high in comparison to Ackerman steering gear mechanism. So why it is coefficient of friction is high? Because in the case of Davis steering gear mechanism, it is a sliding contact. Sliding pair means it's a surface contact. When the contact between the two pairs is the surface contact, the coefficient of friction is high. Whereas in the case of Ackerman, the coefficient of the contact is low. So the point of contact is very small. That is a higher pair. It comes under the category of higher pair. In higher pairs, coefficient of friction is low in comparison to the lower pairs. So this is a Ackermann steering gear. Okay. Here I consider the reference of the textbook I consider for this. Reference is that R.S. Khurmi, Theory of Machines by R.S. Khurmi I considered as a reference. Okay, in the textbook, the chapter name is 9th chapter. So that's why the figure number I considered here, it is 9.17 Ackermann steering gear. Okay, so in that Ackermann steering gear, it is there is the front wheels are there, the rear wheels. The distance between two pivot points is C, and the wheel base is the B. In this case, it is taken left turn. When the front wheels are, when the vehicle is taking left turn, the eye center, instantaneous center is located. It is the extension of the stubs, extension, and coinciding with the rear axle axis. That point is the point of eye center. The eye center is making the front left, in the left turn, in the front wheels, left wheel is making with theta angle and the right wheel is making angle phi. Okay, when it is a straight position, these are the angles. When it takes left turn, the theta becomes here. The C position becomes a C dash, a D position becomes a D dash. The angle made during turn for left wheel is theta and the right wheel is phi. So what is the mechanism here? It is a 4-bar mechanism. A, B, C, D. A, B, C, D. A, B, C, D. So the new position is that when it takes proportionately it moves. So the angle made here, it is theta and it is phi. So that's what happened here. Now let me describe the Ackermann steering gear mechanism from the textbook, that is R.S. Khurmi. The figure shown here 9.17. So that's why I mentioned here the figure is 9.17. Now in Ackermann steering gear, the mechanism ABCD is a 4-bar crank chain. Yes. When vehicle moves along a straight path, the links AB and CD both are in parallel. Links AB and links CD both are in parallel direction. And the shorter links are, what is the shorter links? The shorter links are BC and AD. BC and AD are the shorter links. These are the shorter links, and links AB and CD are parallel, and links BC and AD are shorter links. But these links are making angles to the longitudinal axis of the vehicle. Okay. Now, when the steering is left direction, if you take left, the position of the gear, the positions of the gear is shown with the dotted, not only position of the gears and the position of the wheels. The position of the wheels is shown by dotted lines in this figure. Okay. Now the lines of the front wheels in this position, what is happening? The lines of the front wheels, axle intersect the back wheel axle. This is the back wheel axle and the line of the front wheel axle. That intersection is point known as the eye center. Okay, it is meeting at the point eye center for in order to avoid the skidding of the vehicle, or in order to maintain the correct steering. Not only taking left turn, this eye center should be taken place, should be noted. Not only that, during right turn also, when the vehicle takes right turn, the eye center stub axles becomes this side. In the right side, it comes eye center. So when you are taking left turn, the eye center will be left side. When the vehicle takes a right turn, the eye center becomes on the right side. So in order to maintain the correct steering, or in order to avoid the vehicle skidding. Now, when the vehicle steering is right, the similar position may be obtained. That similar position means the same eye center will be obtained. So one more thing is that now this Ackerman steering gear should satisfy Ackerman steering gear should satisfy the condition of correct steering. Now, in order to satisfy that correct steering condition, the links AD and DC, where the links are AD, these links AD or DC, AD and DC are suitably proportioned. Proportion means to the proportion, if you take left turn, exactly whatever inclination the BC makes, in proportion to that, AD also makes the angle. But the AD, the BC and AD making angles are theta and phi. So the value of theta and phi can be obtained either graphically or by calculations. Now, so that is the description about the Ackerman steering gear mechanism. Now let us see some of the problems which we are going to solve. Now we are going to solve based on this Davis steering gear or Ackerman and condition for correct steering. Let us see here. The ratio between the width of the front wheel axle and that of the wheelbase of a steering gear mechanism is 0.44. At the instant when the front inner wheel is turned by 18 degree, what should be the angle turned by the outer front wheel for perfect steering? Now, we know they asked that it has been given that theta was given, and also ratio of the wheel base, the ratio between the width of the front wheel, front axle and that of the wheelbase, that is W by L equal to 0.44. And one more thing is that at the instant when the front inner wheel is turned by, that is theta is 18 degree, then what about phi? So basically it is not mentioned that what is the condition for a correct steering should be applied or not. Yes, in order to, what is the angle outer front wheel, outer, there is inner front wheel means that is the left wheel. If you are looking from rear axle, from rear wheels, if you are looking towards the front wheels, the left wheel, when you are taking left turn, is the inner wheel, outer wheel is the right wheel. Now here, what should be the angle turned by the outer front wheel from for perfect steering? So that what is the perfect steering means, we have to use the condition for correct steering or perfect steering equation. That equation is cot phi minus cot theta equal to W by L. We know the value of theta, cot phi minus, what is the theta, that is cot 18 degree equal to W by L is 0.44. After substitution, we can know the phi. That phi came as 15.9 degrees. So this is the angle to be turned outer front wheel in order to avoid skidding, or in order to maintain the perfect steering. Now, next problem is that this is the example problem taken from one of the standard textbook, that is Rathan, SS Rathan. Now here, I considered the example problem. I have considered some of the sources. For my references in this presentation, references are, one of the textbook is SS Rathan, and second textbook is written by, problems were solved in the textbook, that is RS Kurmi, and one more is that KL Norton. So I may not mention in this videos as a resources, but all my lectures are followed the books from different textbooks. One thing is that the fundamentals should not be changed. So in the place of cot phi, in order to maintain the copyright issue, if I changed cot alpha or cot beta, then W in the place of W and P and the place of L, it is Q. What will happen? The person who studied in the starting position or initial stage, he can not follow. But the books, if you follow the same Rathan notation, same notation we are frequently following number of years of teaching, suddenly if you want to change it, immediately what will happen? It will be great confusion to the teacher and to the receiver also. So stress, in order to maintain, there are some flaws are there I want to discuss. Suppose stress, what is the symbol for stress? We follow sigma. Suppose if plagiarism is catching the sigma symbol, I want to change the stress symbol sigma. Instead of stress, I use it small s. Then what will happen? This is S is having already for units seconds, and S is also having this S character can be used for so many other repeated. So when I start changing the notations, the standard notations given in the standard books, in order to avoid copyright issues or plagiarism issues, what will happen? There will be a confusion in while reading the person, reader, and also presenter. And once you are changing the notation of sigma stress to S, then wherever S is there, you have to give another letter. So it is initial position, it is changing, you have to change. The fundamentals, the stresses, some of the notations should not be changed, even though plagiarism issues may come, because in order to avoid the confusion. So if I change sigma to S, that means I have written myself. But the concept taken from the source book only, that is the sigma wherever you have studied. So in this manner, we have to absorb and we have to maintain the concepts behind subject should be taken from the standard authors. So in order to maintain in order to avoid the concept copyright issues, if I change my concept, then it is absurd. It is completely wrong. The concept should not be changed. So what the people are doing, the people are changing the letters or notations, okay, in order to avoid the skipping of copyrights issues. Now the point is that as a side topic, so for my videos I am following is that these are my role model, these are my teachers. This SS Rathan is from NIT Kurukshetra, and is the person KL Norton, one of the foreign author. So and also there is Balani also there. There are so many authors, great authors. This PL Balani textbook is outdated now, but the way he mentioned so concepts. So if you read such a standard textbooks, there is nothing, not then our confidence levels will be increased like anything, and you can crack gate questions also, public service undertaking questions very easily. Now here in this problem, the distance between the distance between the steering pivots of a Davis steering gear is 1.3 meters. That is W equal to 1.3 meters. The wheel base equal to 2.75 meters. What will be the inclination? What will be the inclination of the track arms to the longitudinal axis of the vehicle? if it is moving in a straight path, that is alpha. Okay, and some people may ask that how can we know your videos or your presentation is validated? Is there any people are there? Yes. For that type of questions, my answer is that whether I am teaching from the reference textbook or not, or I am teaching outside the textbook, whether I am following word by word, word to word of the standard reference textbooks in my presentation is there or not. If it is there, those textbooks are my standard parameters. So as a person, if I am teaching number of years, I can't change the principles. Newton's law, Newton's first law, second law, third law should not be changed. Similarly, the concepts behind the mechanisms, the concepts behind Davis steering gear mechanism, the concept behind Ackerman steering gear mechanism is standard, whatever speaker may be. So how can we know? You have to validate that. Anybody can validate for what? If I am presenting as it is from the standard textbooks or outside of textbooks I am presenting, but the concepts should not be changed whatever textbook we may be following. If the concept is varying, that means that is non-qualitative teaching. Let me begin with that. Here the distance between here given two pivots, that is 1.3 meters and L equal to 2.75 meters. Now it is a Davis steering gear. According to Davis steering gear, that is tan alpha. Tan alpha equal to, we have that condition, that is W by 2L. This Davis steering gear mechanism is validated with condition where that is perfect steering. That perfect steering is cot phi minus cot theta, that equal to W by L. Now tan alpha we want. What is that alpha? Tan alpha equal to W by 2L, 1.3 by 2 times 2.75 meters. Then alpha equal to tan inverse of, that value will come, that is 0.236, that equal to 13.3 degrees. This is the inclination. This 13.3 degrees, 13.3 degrees is the inclination of the front wheels to the longitudinal axis of the vehicle. There the arms turned, inclination of the arms, that is alpha. Next question, if you see here, the track arm of a Davis steering gear is at a distance of, the track arm of a Davis steering gear is at a distance of 190 millimeter from the front main axle, whereas the difference between their lengths is 96 millimeter. If the distance between steering pivots of the main axle is 1.4 meters, determine the length of the chassis between the front and the rear wheels. Also find the inclination of the track arms to the longitudinal axis of the vehicle. The inclination of the track arms to the longitudinal axis of the vehicle, that means that is alpha. Okay, next determine the length of the chassis between the front and the rear wheels, that is L, that the wheel base, that is the meaning. The length of the chassis between the front and the rear wheels, the front and the rear wheels, this is L, this is W. But what is the inclination? Which mechanism it here? It is the Davis steering gear mechanism. Okay, this inclination, how much it is inclined. Okay, and the distance, this is the height given, H and Y. Now the given data is that W equal to 1.4 meters, H equal to 192 meters, that is the width. This, if the distance between the steering pivots, if the distance between the steering pivots of the main axle is 1.4 meters. So then what is Y? The Y equal to, they mentioned that whereas the difference between their lengths is 96 meters, that is 96 by 2, Y equal to 96, that is 48 millimeter. Now we know that from the concepts of the equation, from the concepts, that is tan alpha equal to Y by H. What is tan alpha equal to Y equal to 48 and H equal to 192? That is alpha getting observed as 14 degrees. Now there is another equation. We got the tan alpha equal to W by 2L. The tan alpha we know, that is 14 degree. Tan 14 degree equal to L, we want L. We know the W, that is 1.4 meters. Tan 14 degrees equal to 1.4 by 2 times L. That L equal to 2.8 meters. Okay, that is the wheel base. That is the first objective was achieved. This is the first objective. What is the wheel base means? Is the distance between the axle, front wheel axle to rear wheel axle. The length, that is the distance, that is called, that is L. That is L is the wheel base. Now they asked inclination. What is that inclination is? The inclination is 14 degree. That is the inclination. The inclination is obtained, here it is 14 degree. Okay, and this is the L is the first objective and alpha is the second objective. But in order to reach the first objective, we have to obtain the value of second objective, that is alpha equal to 14 degree. Then after obtaining the R, if we substitute in tan alpha equal to W by 2L, then that is L is wheel base equal to 2.8 meters. Okay. Now these are the questions we solved in this front wheel axle. And again, let me summarize. Suppose the relation between interpretation, in order to interpret the, if you want to design this Davis steering gear mechanism, then what are the conditions, what are the parameters are required? Now here there are three parameters are there. The three parameters are, number one, inclination, this angle of inclination of the front wheels. Another one is width of the wheels, the distance between the two front wheels, or two pivots of the front wheels, that is W, and wheel base. So when this W is increasing, when W, that means width is increasing, width between two front wheels, between the two front wheels. When W is increasing, that is in proportion to the angle of inclination will be increased, because the relationship shows that it is in proportional to the weight, in proportional. The angle of inclination is in proportional to the distance between two pivots of the front wheels. And when angle of inclination, this W is increasing, and it is inversely proportional to tan alpha is inversely proportional to the wheel base. So what will happen? When the angle of inclination is increasing, the wheel base will be reduced. So we should be very cautious, very careful that, but the design of the chassis are for correct steering, tan alpha equal W by 2L to be satisfied. That means angle of inclination is in proportional to the W and inversely proportional to the wheel base. So when angle of inclination is increasing, okay, in proportional to the width, what will happen? The distance the backside, the distance from that wheel base is reduced. That's why if you see the vehicles, if you observe the racing cars, these parameters, if you observe racing cars, this L is lower in comparison to, okay, when W is increasing, L will be low. When L is high, what will happen? W will be low. So like that, they will follow this relationship. In proportion to that, the geometry, the length or the dimensions of the vehicle will be varied. Okay, this is the examples, and in this session we follow what is Davis steering gear, what is Ackerman steering gear mechanism, and what is the comparison of Davis steering gear and Ackerman steering gear mechanism, and we solve the problems on perfect steering concept and Davis steering gear mechanism. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.